If you guys could please turn to Unit 11, Measuring Length and Area. The area congruence postulate states that if two polygons are congruent, then they have the same area. Obviously, if two polygons are exactly the same, they're going to have the same everything. Excuse me. The area addition postulate is a lot like the angle addition postulate, the segment addition postulate, the arc addition postulate. Basically, it says the area of a region is the sum of the areas of its non-overlapping parts. So, for example, if you had a figure that looks like this, it looks kind of like a house, you have a square with a triangle on top, and you wanted to find the area of this figure, you could find the area of the triangle, the area of the square, add those two areas together, and you get the total area. Alright, these are formulas to find the areas of different figures. Some things to keep in mind: rectangles and parallelograms have the same area formula. Also, rhombuses and kites have the same area formula. Okay? Also, either pair of parallel sides can be used as the basis of a parallelogram, and the height is the perpendicular distance between these two bases. So, in this case, if I were to turn this parallelogram sideways and draw a height from this base to this base, you would get the same exact area. Okay? The height of a triangle is the length of the altitude drawn to the given base. Okay? And also, remember that a rhombus is also a parallelogram, so you can use this formula, or you could use this formula for a rhombus, because a rhombus qualifies as a parallelogram. Okay? Alright. If two polygons are similar, then their scale factor is going to be the same as the ratio of their perimeters. So, if you remember, scale factor is the ratio of the corresponding lengths of two similar polygons. If the polygons are similar, the perimeters are going to have the same ratio. Also, their areas, so for example, if you have two polygons and they have a scale factor of a to b, the ratio of their areas is going to be a squared to b squared. Alright. The area of a circle can be found with the equation pi r squared. The circumference of a circle is the distance around the circle, kind of like the perimeter of a circle. And this can be found with either of these equations, either 2 pi r or pi d. R is the radius, d is the diameter. Excuse me. An arc length is a portion of the circumference of a circle. You can use the measure of the arc in degrees to find its length in linear units. Okay, so let's say this arc is 90 degrees. Okay? The ratio 90 over 360 would be the same as the ratio of the length of this arc, whatever it is, to the circumference of the circle. An area is very similar. If I wanted to find the area of a given sector, a sector of a circle is the region bounded by two radii of the circle. So in this case, if I have this radius and this radius, this would be a sector of a circle. It's the region and their intercepted arc. Okay, so if I wanted to find the area of this sector, I could use the measure of this arc, the ratio of the measure of this arc to 360 degrees, the same way I did for the arc length. Alright, the diagram here shows a regular polygon inscribed inside a circle. The center of the polygon and the radius of the polygon are the center and the radius of its circumscribed circle. Okay, so the center and the radius of the circle is the center and the radius of the regular polygon that I've drawn. The distance from the center to any side of the polygon is called the apothem of the polygon, and I've labeled it A. Okay, so apothem PQ is labeled A. The apothem is like the height to the base of an isosceles triangle that has two radii as legs. A central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices of the polygon. Okay? And if you want to find the area of a regular polygon, you can use this equation or this equation. You already know that A is apothem, P is the perimeter of the polygon, and N is the number of sides. So depending on what information you're given, you can use either this equation or this equation. Also, sometimes a problem, depending on how the problem is presented, you may also have to incorporate your knowledge of the Pythagorean theorem or special right triangles or trig functions to solve the problem. And I've made a list of what you would need to know in order to use each of these things, and we'll do some examples of this in class. Alright? The probability of an event is a measure of the likelihood that the event will occur. It is a number between 0 and 1 and can be expressed as a fraction, decimal, or percent. So let AB be a segment that contains CD. If a point K on AB is chosen at random, then the probability that it is on CD is the ratio of the length is the ratio of the length of CD to the length of AB. The way we represent probability is with a P, and then whatever event we're discussing goes in parentheses next to the P. Okay? Now, let J be a region that contains region M. If a point K in J is chosen at random, then the probability that it is in region M is the ratio of the area of M to the area of J. And that's all for Unit 11.